Maytag 2-cylinder crankshaft bushings is the project for today. And as you can see, it's quite loose. It's evident immediately that this bushing needs to be replaced. That's too much play. And what happens is when that gets play in there, when it's too loose, then it can suck air between the crankshaft and the bushing. Therefore, it don't have any suction on the fuel jet. It don't have any suction. One of the things that some men recommends is replacing this oil ring retainer with a oil seal. Once you put this seal in there, then air can't come out this way. And what you're doing is you're starving that bushing for oil. If your bushing is wore bad enough, do not put this in here as a stopgap. If it's wore that much, then you need to replace the bushings. To remove these is you just take a screwdriver and pop it right out. Now I will, when this one, I should have shown you that first. This one was, when somebody put it in there, they drove it all the way down to where that it bottomed out against the bushing. It don't supposed to do that. This one is correct. When you look across through yonder like that, it is even with the housing. This one is not correct. It's too far out. It should be down a little bit more. By all means, do not use an oil seal in place of an oil retainer. These two side outboard bushings, they are really tight, so there's no reason for me to replace these two. And as you can see, they're just, well, I can't make that any better. Now, carrying right along after all of that, we will put them back in. When you buy a bushing at the store, this is what you get. And it's the size for the crankshaft. Now, at this point, if your crankshaft is worn too much, then a bushing will not fix that. It has to be a worn bushing that is at fault. I have seen them where the crankshaft is worn. Once that wears where the bushing fits at, this is one already machined. Once it wears there, then you can't get, especially on this side over here, if it wears, but where that bushing is, then if you make a bushing with a smaller hole in it to be that size, then you can't get it on the big part out here. So if this is worn out, then this will not fix it. Now, when you buy the bushing at the store, this is what it looks like. It's too big. It's, as you can see, this one happened to be 2 inches long, and the one that Maytag uses is 1 3/4, which is 1.750 thousandths. So I've already turned several of these down. I've got a bunch of them to do, and I did turn these down, and in order for that bushing to fit on the crankshaft, you have to turn that little sharp edge right there. You have to put a radius in it. Okay, to turn that radius, and I did this in the big lathe, that part, cutting it off 2 lengths and the radius. And what I did is I ground me a form tool bit that it's a half of a, actually it's a quarter of a circle. And when that goes right in there, it will cut that half of that quarter of a circle that you need to confirm to the crankshaft. So simple, easy too. But anyways, this one's been cut to length. It's been radiused on the inside to fit. It comes to mind that I should mention something. I've cut a couple of crankshafts apart recently, and this hole that goes into the crankshaft right here, this whatever degree of opening that is. It's machined to a precise measurement to let the fuel into the crankcase. Okay, that hole in there goes all the way through, all the way down to this cross hole here. That confirms into the original bushing. That's where you get most of your oiling, and if you see where it's at, it's that far down. So Maytag knew that you need to get some additional lubrication down there other than what would migrate down the crankshaft. And these spirals here are turned in a backward spiral in order to make the lubricant to come back into the bushing. You are supposed to have a small amount of loss, very little. But what I'm pointing out is this hole goes all the way across, continues through the crankshaft like this. That hole continues right on through on this side, and that's where you get your lubricant for the bushing. Now, at that point, the reason I'm taking the time to talk about this is this crankshaft here was broken, and I cut it off to make a tool out of. And when I looked at it, and I don't know where this crankshaft come from, what part of the country. It's no problem here where I live, but I have run into this several times here lately, enough for me to take the time to bring it to your attention. When you buy these engines from wherever you get an engine at, when you bring it home, don't assume it is a good engine. Take it apart. This being the reason why. This cross hole is completely stopped up. It just won't go through there. Now, if you could see down in yonder, I can see it here on site. It's a dirt dauber nest down in there. And I've not poked at it, but if you poke on through yonder, and you see that? It's a dirt dauber in yonder. Okay, this engine right here, had someone install this crankshaft into an engine, this bushing would have never got any oil to it. I'm just telling you, you need to be vigilant on stuff like this right here. Let's see where we at. I've cut the bushing off, and I did. The outside of this bushing is the new one, measuring it on the micrometer, is 1.065. Okay, the inside, and I do have several that I have done in the past, and if you'll put the micrometer on one that I have extracted, the size will be on all of them 1.060. All of them that you take out will be that size. So, in order to get this one to a size that when you press it into the housing, that it does not compress the inside of the bushing to the point you have to use a reamer, then what you do is you turn the outside down uniformly, not crooked, not askew. You turn it down to 1.061. That will give you a 1,000th interference fit, which for cast iron, this instant, I'm sure that is acceptable. And at that measurement, you won't compress the inside of it enough to where you have to ream it. Now, the correct procedure to do this is to line bore the engine, meaning that you would assemble this all together with two bushings that were undersized. And then you would run a reamer completely through both bushings at one time and ream both of them true to the engine block. That's the correct way to do it. I do not have a reamer that long to do that. So this way right here works really good for me, simply because most crankshafts are worn a few thousandths